Hi everyone, we're going to determine whether the following sequences have limits. This is part 1, and these are the 5 problems I'm going to do. So if you just want to scroll through the slides to pick one, you can do that. Okay, so we're going to get started. The first one, I'm going to look for my nth term, and my nth term for this pattern is there's 2 on the top, and then that would be n. So that would be a sub 1, a sub 2, a sub 3, and I'm just matching up these numbers here. So that's my nth term, and therefore I'm going to take the limit as n approaches a huge number infinity of my a sub n. So that's going to equal the limit as n approaches infinity over 2n. And if you want, this can be written as 2 times 1 over n. So I can write this and pull the 2 out. Limit as n approaches infinity of 1 over n. We know that when you put a big number in this goes to 0. So the limit of this is 0. You get 2 times 0 equals 0. Okay? And the next one we want to find the nth term. So if I have this as my first term, second term, third term, and fourth term, and basically I'm trying to match these numbers up here, and therefore what I'm going to get is my nth term is going to be n minus 1, because n minus 1 is 0 over n plus 1. And so this first one, this would actually be 0 over 2, which is equals 0. So therefore, we're going to take the limit as n approaches infinity of this, or my a sub n. So this is going to be the limit as n approaches infinity of n minus 1 over n plus 1. And when you do that, what I can do for this is go ahead and divide all of these pieces by n. And if you do that, you get 1 minus 1 over n over 1 plus 1 over n. And then the way I can write that, I can split all this up. I'm going to go ahead and just take 2 steps and just write this as the limit as n approaches infinity of 1 minus 1 over n. And then this is the limit as n approaches infinity of 1 plus 1 over n. Now take the limit of each piece, so you get the limit as n approaches infinity of 1 minus the limit as n approaches infinity over 1 over n. Well, what's going to happen here, so we're dealing with this part, that's going to be 1 minus 0, so that's going to equal 1. And if we do this one, so I'm just going to change this to a plus, I'm going to get 1 plus, because remember this is 0. And because the bigger the number you put in, you get 0, so you can get it 1 plus 0 equals 1. So 1 divided by 1 is 1. Okay, the next one is this one. So again, we're going to try to find the nth term. This would be your first term, second term, third term, and so forth. So I try to match these index numbers up. So I see this. That's going to be a sub n equals n squared, so I'm just squaring that number there. And for the denominator, I'm just getting 2 times my number. So 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, and then 2 times 4 is 8. So that's just be 2n. All right, So now we're going to take the limit as n approaches a big number of n squared over 2n. And I'm going to simplify that. I'm going to simplify that. I'm going to get n over 2. N over 2 is the same as 1/2 times n. So we're going to get the limit. I'm going to pull out the 1/2. The limit as n approaches infinity of n. And what happens is the limit of that is just infinity. You get 1/2 times infinity, so there's no limit. So no limit exists. Okay, and the next one is this one. And I'm going to write all this out. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is -1. And sine of 2 pi is 0. And it's just going to keep repeating. So then you're going to get 1, 0, -1. Keeps repeating, and there's no limit because it doesn't converge to anything, so no limit exists. And the last one is this one. So basically finding my nth term, this is 3 and that would be 4. I'm going to write this as my nth term is going to be 10 to the n minus 1 over 10 to the n power, or this can be written as 1 minus 1 over 10 to the nth. So we take the limit of this. I'm going to take the limit as n approaches infinity of 1 minus the limit as n approaches infinity over 1 over 10 to the nth. And what happens is this is going to equal 1 because that's just a constant. And as this number gets bigger and bigger, the total of this is going to go to 0. So you get 1 minus 0, and that equals 1. Okay? The next set is going to be similar. It's going to have log and cosine and sine in it as well. Thank you. Have a nice day. Bye-bye.